Hi, stats people. This is our part 2 of 5.1 notes dealing with the introduction to probability. So in this section, we're going to focus on how to run a simulation, what type of information we can get from simulations. So in our book, they ask us to follow, and they will repeatedly call this main step, state, plan, do, conclude, is what our book uses. I've seen other things where in the past I have used some version of CAT CCC as a method to remember all the steps. I went and I looked up this year a grading rubric from an actual AP. And these were the main parts that they were looking for when they were giving points. So I thought we'd try that this year and say, okay, the scheme, what are you going to do in order to create the simulation? How do you know when to stop? What are you counting? Are you going to ignore repeats or not? And then what do you conclude? Now we've done a little bit of this about using a random number table and assigning whether things happen or not. This time we're going to use it specifically for the purpose of trying to calculate some probabilities. All right, so let's take a look at our first one. So it says, in an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. Each box of cereal will contain a collectible card featuring one of the NASCAR drivers: Jeff Gordon, Dale Earnhardt Jr., Tony Stewart, Danica Patrick. Okay, so this must be a little bit old. And Jimmie Johnson. The company says that each of the 5 cards is equally likely. So I'm going to highlight that so I don't remember that. They're each equally likely to appear in any box of cereal. A NASCAR fan decides to keep buying boxes until she has all five drivers' cards. She's surprised when it takes her 23 boxes to get to the full set of cards. Should she be surprised? All right, so we don't really know for sure. I mean, we can do some probability calculations and everything else, but maybe on this one it would say like run a simulation to see, okay? So first thing that we would want to do is we would want to describe our scheme. If we're going to use a random number table, and I'll print out some of the numbers here for us to use. Or let's even do the first one with just using our calculator and using random integer for that, okay? So I would want to start out by telling them what my main plan is, right? So first thing I would do is the scheme, okay? So we are trying to we are simulate number of boxes bought to get all 5 drivers. Okay, that's our scheme, is we're going to simulate that. The next thing is we want to plan out what numbers in our random number table that we're going to use. So since these are 5 different drivers, we don't have to go very far. We can use single digits. So I may say something like, let's use 1 is equal to Jeff Gordon, 2 is equal to Dale Earnhardt, 3 is equal to Tony Stewart, 4 is equal to Danica Patrick, 5 is equal to Jimmie Johnson, and those are the only numbers we're going to use. And if we're going to use a random number generator, we can actually tell it that that's all we're going to use. Okay, so that's the part for scheme. All right, next part is how will you know when to stop? Okay, so we're going to use a random number generator. So we describe, so use a random number generator. And remember the formula here is you say the lowest number, the highest number, and then how many you want to pick. We don't know how many to pick, so we're just going to do that. So we're going to use a random number table from 1 to 5 to simulate buying a box and work when we have 1, 2, 3, 4, and 5 collected. In this case, we are not going to ignore repeats, right? Because we actually want to count them. If I have to open up a box and there are 3 of them with Tony Stewart in them, that's fine, then I have to count those, okay? So we are going to say count repeats. Okay, so in the second step there about what are you actually counting, and I've actually already included the replacement part as well. Okay, so now we're going to do it, and then we're going to make sure we do a conclusion statement. So let me move this over right here. I'm going to pause it for a second to go get my calculator. So I grab my calculator. So I'm using my graphing calculator. I'm going to go press math over to probability. I'm going to do random integer, and I'm going to tell it 1, 5, and For me, it's easier to see them on the screen if I do them in groups of 5. So I'm going to go ahead and enter this as RNG 1, 5, 5, and that's just so that I can see 5 at a time, okay? So the first 5 that I get are 5, 3, 3, 2, 5. So what I can see, and I'm going to just put check marks next to them, we already got this one. We got this one twice, we got this one, and we got another 5. So I'm still looking for a 1 and a 4. So I'm going to press it one more time, and we'll see what we get this time. This time I get another 5, I already have that one. I get a 3, I already have that one. I get a 4, ooh, got that one. I get a 5, I already have that one, and we get our 1. Okay, so in our first try, so I might call this trial 1. In our first try, it took 10 tries. Okay, so the next thing would be, how many times should I repeat this to give them an answer, right? She had to open 23 boxes. So right now, I don't know whether 10 was like a weird event that happened for me or if this is a typical answer. So they might tell you, or our general idea is you always do at least 3. Okay, so I'm going to go into another trial. I'm going to call this trial number 2. I'm going to do the exact same thing again. So this time I'm going to do 5, 5, 4, 4, 3, not making this up. This is what's coming up on my calculator. So now I have a 5, a 4, and a 3. Press the next groups of them and I get a 1. A 1, I already have that. 5 and a 4, I already have another 1, so I'm going to have to press it again. And this time the very first number is a 2, so I would stop, right? That's all of them. So this time it took 11 tries. Okay, so I'm going to do it one more time. Let's see, let's do a grade 1 this time. So trial 3. Repeat again. So this time I'm going to get a 2, 2, 3, 3, 3. So I've got a 2, I've got a 3. The next one is a 5. Got my 5. A 1. Got my 1. Another 1, another 1, and a 3. So what am I still looking for? I'm still looking for a 4. So the next one is a 2, I already have that one, and a 4, there it is. So this one took 12 tries. All right, so what's my conclusion? So my conclusion would be something about, hey, we didn't have to do anywhere near 23 of them, right? So my conclusion statement might say something like, on average, we had to buy, so let's do an average, right? So 10 plus 11 plus 12 divided by 3 would be 11. Okay, we had to buy 11 boxes in order to receive each driver's card in the cereal box, right? So what do we think about hers, right? The question was, should she be surprised that it takes 23 boxes? And we would say, it seems very unlikely, let's try that again, very unlikely that she would need to buy 23 boxes. Right? So we're trying to give a little bit of a longer run average. Obviously, they understand that this whole idea of simulations can be a little bit tedious of writing down all these numbers. So they want to give you a little bit of room here by only making you do 3 to kind of represent like our long run average. Okay. All right. So that was one where they were all equally likely. Let's take a look at the next one. At their annual picnic, 18 students in the math and stats department at a university decide to play a softball game. 12 of the 18 are math majors and 6 are stats majors. So we have 12 are math and 6 are stats. To divide into 2 teams of 9, one of the professors put all the players' names in a hat and drew out 9 players to form one team, with the remaining 9 players forming the other team. The players were surprised when one team was made entirely of math majors. Is it possible that the names weren't adequately mixed in the hat, or could this have happened by chance? design and carry out a simulation to help answer this question. All right, so here we go again. Our very first thing is to kind of scheme and say what we're trying to do. So we're trying to find out the probability, right, of how likely it is. So we started this one to say, simulate the number of boxes, right, that we had to buy. So this time we're going to simulate, what should we simulate? How would I do this? So maybe I could use numbering in one, yeah, let's just practice doing what he did out of the hat and see if we get players like this, right? So what are we gonna count at the end? So, okay, so let's start out with, we're gonna simulate the probability of getting a team of all math majors, right? That's basically what we're going to try to do here. So again, if I wanted to use a random number generator, right, then I would say something along the lines of, let's decide how we're going to number these, right? So we have 18 students that are, or 18 teachers that are playing, or 18 students that are playing. So we would do that numbers 1 through 12 are going to be math majors, and 13 through 18 are going to be stats majors. Okay, all right, so the next step is, how do we actually go about it? Right, so we're into the what are we actually counting, and are we going to ignore repeats? So we're going to use a random number generator. So use a random number generator, and this time we're going from 1 to 18, and we're going to pick a team of 9 and see if they happen to all be that from that group 1 through 12. Okay, so I'm going to pick a group of 1 through 9, and we're going to see if they're in a group of all math teachers, or all math students, sorry. And when do we stop? Well, it's not really a matter of like, when do we stop? We just go and see if we picked out 18 people, what would it look like for the 2 different teams? What about repeats? So here I would ignore repeats, right? Because I can't put a player on the same team twice, and I can't move a player from one team to the other. So we're going to say ignore repeats until 2 teams are determined. Okay, when I do that, what am I going to say at the end, right? So let's say that I got 9 on a team that are math majors. That's kind of what I want to count. It's how many times do I end up with 9 that are math majors, right? So I'm going to count the number of trials where there are 9 math majors on a team. Okay. All right, so here we go. So on this one, I'm going to turn on my calculator. I'm going to go to random integer. Again, I'm only going to do 5 at a time because it fills up my screen really nicely. Okay, so random integer, I'm going to do 1, 18, pick 9, or I'm going to pick 5 to go in my screen, right? So my first group is 11. Change colors here. My first group is 11, 15, 13, 5, another 15, which I'm going to ignore, right, because that's a repeat. So far I have 4 people on the team. Okay, and then I'm going to do the next group of 5, and it's another 5, so I ignore that. Then I have an 18, a 13, a 12. So now I have 1, 2, 3, 4, 5, 6 for 12. I've got an 18, I have to cross that one out. So 1, 2, 3, 4, 5, 6. The next one is player 9. Player 15 is a repeat, player 1. So 4, 5, 6, 7, 8. And the last one is 11, which is still a repeat, so I have to continue, and I got a 12. Okay, so my first 9 happen to be these players. Are they all math majors? No, right? I've got some that are above 12, so this is a mix. What about the remaining ones? Could the remaining ones be all math majors? Well, in order for the remaining ones to be all math majors, right, we should have all of the stats already counted here, right, in order for the other team. So where are the 1 through 12, where are the rest of the 1 through 12, right? So if this is team A, then let's go check out who team B would be for the two teams. So we already have a 1, so we know they would be team player 3, 4, 2, 3, and 4. 5 is already up there. We'd have player 6. We'd have player 7, it looks like. We'd have player 8. 9 is on the first team. We'd have player 10. 11's on the first team. 12, 13 is on the first team. So we'd have 14. And 15 is already there. Looks like we would have player 16. Somewhere in here, I have a repeat. Let's see if we can figure out where it is. So I see a 1, I see a 2, I see a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, 11, 12, 13, 14. Where's 14? There it is. 15, 16. So did I pick too many for the first group? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm okay. 4, 5, 6, 7, 8, 9. Oh, I have them all. Okay, cool. All right, so is this team going to be all math majors? No. So this is one trial. Okay, so in one trial, we got a no. We did not have the problem of having all math majors on one team. So we're going to do this for 3 trials, and again, check this. So for trial 2, we start again. Okay, so this time I'm going to get a 5, a 17, a 16, a 6, and an 8. Then the next group is a 5, which I cross out, a 2, a 15, a 4, and a 10. I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are they all math majors? They are not. So team A is a no. Team B would have 1, 3, 4, 7, 9, 11, 12, 13, and 14. What else did I reuse here? Oh, 4. Okay, so I can't have 4. I'll go erase 4, and we'll put in its place. We have 15, 16, 17, and 18. So obviously team B does not have it either. So for trial number 2, we did not end up with all of the teams being like having a whole team with math. Okay, so we do it one more time. Are we noticing that this is a little tedious, right? Okay, so here we go again. Our first ones are 7, 12, 5, 7 I have to cross out because it's a repeat, 10. So notice I am writing down the repeats, right? I'm writing down exactly what comes up on my calculator and then just crossing out the repeats. So I have 4. The next group is a 3, a 10, that gets crossed out, a 9, don't have one of those yet, a 16, don't have one of those, so 3, 4, 5, 6, 7, 17, and then another 6. Ooh, we don't have a 6. Okay, so 3, 4, 5, 6, 7, 8, 9. There is team A. Are they all math? No, we have a 16 and a 17. What about team B? Well, the ones that are left would be 1, 2, 4, 7, it looks like. Nope, 7 is there. 8, 9 and 10 are already taken. 11, 12 is already taken. 13, 14, and 18. Is team B all math? No. So in our case, we had 0 out of 3 times where this happened as a probability. We never got in our 3 trials a team with all math in them. So then our conclusion would be in our 3 trials, right? In our 3 trials, we never got a team of all math. In our trials, our probability of getting all math team was 0 out of 3, which is 0% chance. We would call this unusual then because of our trials. Okay, now obviously it'd be nice if we could do this 100 times and see how possible that is, but that's way too time consuming. All right, last one. I hope this is the last one. I don't want to do another one. Okay, we're going to make this one our last one. All right, so on this one, assuming that all colors of M&Ms, and we listed them there, it looks like there are 6, are equally likely, I got 3 red M&Ms out of 5 in a handful. What is the likelihood of this happening? So let's suppose, no, I think that's a typo. Okay, so let's design and carry out a simulation to answer the question. Start at line 101 of table D and use a different line for each trial. And it says do 20 trials. Now that sounds like a lot, but remember, I'm only picking out 5 at a time. Now, table D is in the back of your book. Okay, it's near the index and the glossary stuff, and it will say T up in the right-hand corner when you are in the right section. So I'm bringing that one up as we speak, and there it is, table D, random digits. Okay, so we're going to again start out with what is our plan? Like, what are we planning to do? So let's see. We want to simulate picking 5 M&Ms and seeing how many are red. Then we're going to find the probability of getting 3 red. Okay, all right, so we need to number these. So numbering these, it looks like since they're all equally likely, 1 is going to be, I'm not color coding this, it'll take too long. 2 is going to be orange, 3 is going to be yellow, 4 is going to be green, 5 is going to be blue, 6 is going to be brown. I'm going to use W for brown since all the rest have been used. Okay. So now this time when I use a random number table, it's going to have all the digits in them. So in this case, I'm going to say start at line 101, like they said, line 101, label each 1-digit number. We're going to keep repeats, but ignore any digit that is, so we're going to ignore 7 through 9, right? Because they're not going to fit on our plan, all right? All right, so here we go. So trial number 1 on line 101, and I'm just going to write them out, is 19223. Okay, and then I'm going to put a few of these in a row since we're going to do this 20 times. The next one is 950. Oh, I have to make sure I get 5, right? So hang on a second. So this is going to take longer. Maybe we won't do all 20. So because I could get these, I have to cross out the 9 and pick the next one over, which is another 9. So I'd cross that one out. And then the next one over would be a 5. Okay, so there is 1 trial. Okay, then I would go and pick up right from where I left off. And I got a 0. What the heck do I do with a 0? Oh, I never accounted for that, did I? So I should go back and I should say ignore 7 through 9 and 0. Okay. All right, not a big deal. So I'm going to cross off 0, keep going. I'm going to get a 3, 4, 0. I'm going to cross out a 5, a 7. I got to cross out the 7. I still only have 3 so far. And then a 5, and then a 6. Okay, let's do another group. So we're going to have a 2, the 8 I cross out, the 7 I cross out, a 1 and a 3. Then I get a 9, I cross that one out, a 6 and a 4. Okay, so in our 3 trials so far, let's go see, was it possible? What I'm looking for is to get 3 reds. So I'm looking for any of them that have 3 number 1s in them. So far I've gotten none of them that have 3 1s in them, right? Okay, so then the next one, keep going on here. So we ended up at 6, 4. So the next grouping would be a 0, we cross that out, a 9, we cross that out, a 1, 2, 5, 3, 1. That one had 2 reds in it. Next one is 4, 2, 5, 4, 4. Okay, that one had 3 number 4s. It had 3 green ones in it, but they wanted to know how likely it is to get 4 or 3 reds, right? So if they would have named it differently, or if I would have interpreted it differently to say, what is the possibility of getting 3 of any one color? So maybe we'd want to go back up there and say, maybe that would be more accurate, right? Like how possible is it to get 3 of this exact same color? We want to simulate picking 5 M&Ms and seeing how many, how likely it is to get 3 of one color. Okay, so now I'm just looking for 3 of a kind, right? So this would be a no. This one would be 1, 2, right? No, I don't have 3 of a kind. I don't have 3 of a kind. Okay, I don't have 3 of a kind. And this one I do. Okay, so let's say that we're going to go and do, let's try and see if we can get through 10 really quickly here. Okay, so the next one is going to be an 8, ignore that, a 2, keep it, 8, ignore it, 5, 3, keep both of those. I've run out of line 101, so I'm going to go down to line 102. So the next one is a 7, get rid of that, a 3 we keep, and a 6 we keep. So that one is also a no. So we have 6. On to the next one would be, let's see, a 7, that's a no. 6 we keep, 4 we keep, 7 we throw away, a 1, a 5, a 0 we throw away, and 2 9s, throw both of those away, and a 4. That is not 3 of a kind either. On to the next one. I get 2 zeros, cross those out. I get a third 0, cross that out. I get a 1, a 9, a 2, and a 7. A 2 again, 2 7s. So I've picked out how many so far? 2, 3. Okay, then I get a 5 and a 4. So this one also was a no. So this was a no, this was a no, this was a no. Okay, so we would tell them how many times we're going to do this at the very, very beginning. So instead of doing 20, I'm going to change the rules because I'm allowed. And we did 1, 2, 3, 4, 5, 6, 7, 8. We're going to say we did 8 trials. Okay, so in all of our 8 trials, how many times did we get 3 of the same color? We only got that 1 out of 8 times for probability, right? So we could say in our 8 trials, the probability of getting 3 of the same color is 1/8, which would turn into 12.5%. And that's based on our 8 trials. Good. So what do we think? We think that this event is fairly rare, right? So 12.5 is pretty low. It's not statistically significant. We didn't get as low as 5% or less, right? But we would say that this is a pretty low probability. Pretty low probability, not very likely. Okay, we're still using that word statistically significant. Anytime it's less than 5%, okay, we can say that is statistically significant. Cool. All right, that's it for this one. We will let you go on simulations. See you next time.